thoughts on number 1? Take the zeros and the multiplicity of each. That's easy enough. What are our zeros? -4, and that one has multiplicity 1, right? So really no multiplicity, but yeah, 1. That's a single zero, simple zero. How about, where's another one? -1, and that one has multiplicity 3. See how it squiggles? And then another one is at 3, and it has multiplicity 2. Everybody good with that? Use limits to describe the end behavior. So remember, that means this. Is this thing named? So what are we going to say? What is our end behavior? On the right side, oh, and the left side, negative infinity. Everybody good with that? Okay, perfect. I got some function called k, and I want to know if it's even or odd, and I have to prove my answer. So let's back up and remember, what's the definition of an even function? If k of x is even, what's going to happen? Charlie?
The function is symmetrical across the y-axis.
Bingo. What does it mean algebraically in function language? But yes, you're right, graphically that would be the case. K of negative x is the same as k of x if it is even. We're going to read these things.
Okay, thank you.
Okay? What, I'm just writing the definition for now. What if k is odd? K of negative x equals negative k of x. Okay, that's, you have to show, prove, demonstrate, whatever verb you want to use, that we are even or odd. This is where you start. If you don't have the equation, if all you have is the picture, then you're going to go with what Charlie said. If you are even, you have symmetry about the y-axis. If you are odd, you have symmetry about the origin. Okay? That is not a proof here. That would be if you were addressing a picture. Okay? We are addressing an equation. So let's find k of negative x, because that kind of is the hinge here. So k of negative x would be negative x cubed plus 4 times negative x plus 2. Negative x cubed minus 4x plus 2. That's k of negative x. Does k of negative x equal k of x? Are these the same thing? What does that mean? If they're not the same, then we are not even. So, since k of negative x does not equal k of x, k is not even. Okay, there you go. Now, does k of negative x equal the opposite of k of x? No. Since k of negative x does not equal the opposite of k of x, k is not odd. Therefore, what was the question? Even, odd, or neither? This is a neither. Everybody okay with that? And then we got Charlie's question here. An even function has symmetry about the y-axis. Very good. Okay, given the indicated residual plot, state whether the model used was appropriate or not. So we're just going to look at these residuals and we're going to decide if the given model is appropriate or if the given model is not appropriate. We don't have the model. We have no idea what the model was. We have the residual here. So for they're not labeled or anything, top left, first one, would you say that model was appropriate? Yeah, it's pretty random. Yep. How about the top right? No, not appropriate. How about bottom left? I would say that's pretty appropriate. It's kind of random, right? What about bottom right? I don't think that's too good. Isn't that pretty predictable? Same number of dots everywhere? Yeah. All right, part 5. What type of model is represented by the data? Take a few minutes with your partner. Take a few minutes with your partner and figure out whether these guys are, what are our options? Linear, quadratic, exponential at this point. Any thoughts about this yet? What do you think about A? Quadratic. And how would you explain that? Leo?
It increases and it decreases.
And not only does it increase and then decrease, but did you notice your x's are equal length, and did you notice your y's are kind of balanced? It's kind of going up, symmetric in other words. So yes, quadratic, good. What about B? B is absolutely 100% linear, because we're going down by exactly the same amount each time. And then C, exponential, aren't we multiplying by the same thing each time, proportional? Everybody okay with that? Number 6 addresses that in words. A linear model is best if the differences between y values over equal intervals of x is a constant. That's what linear means. Second bullet, a quadratic model is best if the differences between the differences is constant, as long as our x's are evenly spaced. And then the third bullet, an exponential is best if the proportions between the y values over equal intervals of x is a constant. You hopefully know that, right? Right. Given this residual plot, what is the meaning of point meaning of point A? Can anyone put that into words? Charlie?
The graph overestimated by 0.3.
The model overestimated by, 0.30952 or whatever. How does Charlie know that? Because when the residual is negative, that means the model was bigger than the actual. So that's an overestimation. Thank you, Charlie, very good. Match the equation to the graph. Okay. So there's our first graph. Here's our second graph. By the way, when you are drawing your own exponentials, like you did in a homework recently, make sure you're indicating where the asymptote is. If it's not the x-axis, make sure you're indicating where it is. Okay, so we have 2/3 for the negative x. We have 1/2 negative 3 to the x. And negative 5, 3/2 negative x. Okay. Now, when I make up problems, Lord only knows what happens. Let's see. Let's see. What did you think about this first one? Did you find a match for this first one? Did you rethink this as 3/2 to the x? And since 3/2 is more than 1, that's going to be a growth. So did you match it to this one right here? Okay. All right. What about this one? Well, forget that for a second. This right here would be a decay. Would everybody agree with that? But I'm dropping it down to, so wouldn't it look like this? Do I have that one up here? Of course not. So that should look like this, because it's gotta be decay. This is a growth, drop down a couple, but that would work if I made the exponent negative. But it's not, so that one has a match. It would look like this. How about this one? That's a growth. Upside down. Do I have that up here? First one? Are we following along? Everybody good? All right, and finally this one, there's a lot going on here. Let's take care of that exponent first. So this would be 2/3 to the x. So that's a decay. Flipped upside down. Do I have that one up here? That should be this one. The last equation is this one right here. Are you okay? All right, okay, next page. Find a sub n and a sub 13. If the sequence is arithmetic, and then if it's geometric. All right, take a second with your partner, see if you can figure that out. You can use a calculator on the starred problems. You should be prepared to do the other ones without a calculator, but the starred ones you can do it with.
Which one, is it AS0 or AS1? I just said like in the line, like when you have it right.
right, what do you think, guys? Anybody willing to come up and put your work on the board, or A or B, or both? Okay, what do we think? Okay, what do we think about this? Here is the arithmetic equation. Is this what you guys got for your arithmetic equation? And then her value was 25 when she plugged in 13. That looks good. Over here for geometric, now remember when it's geometric, we have 310 and 716. So we got r to the fourth here. We're doing 4 multiplications, and the total multiplications is 16/10 or 1.6 or 8/5. How do you want to think about it? So we fourth rooted and got that as an r value. Does that make sense to everyone? And then What's this, Charlie?
That's me getting the first bite.
So he says, I know my third term is 10, and I'm multiplying by this to get from term to term, so he divided by 2 of those to get his first term.
Yeah.
Okay, and then, so is that right, is that the right number? And then he said, okay, so my nth term is gonna be that guy times my ratio to the n minus first. So you took that times your ratio to the 12th, and this is what you got. Now the only thing I wonder about is there's a lot of round off error in here.
Yeah.
So let's try, when you have to write it down, you have to write it down, so that's fine. But in terms of doing the calculation, instead of typing in 7.905, maybe use this answer, so you have the whole thing written out. And then maybe, where did this come from? This came from taking the 4th root of 1.6. So maybe in terms of actually doing the problem, instead of typing in that rounded off thing, maybe just type the 4th root of 1.6 and then raise that to the 12th power. And it is gonna cause some difference there. Not a huge amount, but significant enough that if we're rounding to the 1,000th, already off, okay? We try to only round once, and that's at the very end, in terms of working through the problem. But yeah, nicely done. Everybody okay with that? Anybody have a question? Using limits, express the end behavior of this. Anybody got this done already? Some of you I know are looking ahead, which is great. Keep looking ahead. What does this thing look like? We better take care of that negative, right? So this is 3/5, 1/4 to the x. So isn't that just gonna be a regular decay? So the limit on the left is infinity, and the limit on the right is 0 from the top. Now, if we tack the +2 on the end of that, what would that change? Would move it up to? So the limit on the right or left is still going to be positive infinity, but on the right now, it would be 2 from the top. Rewrite the general form y equals ab to the x, where a and b are positive. Okay, so in other words, get rid of the horizontal translation. Lily, have you done this one yet? You got what?
1/16.
Yeah, she's exactly right. So 1/16 times 4 to the x. Because this is 4 to the x times 4 to the -2nd. And 4 to the -2nd is 1/16. Beautiful, beautiful. Anybody get B done? Anybody got that one? Basically, did you do that one already?
Yeah, I did 2 times 6 to the x and then 6 to the first. And then that would become 12 and then 6 to the x.
Beautiful, beautiful. You okay? And then how about the last one? You've been doing a lot of this lately, it seems like. Anybody do anything with that one?
I did 16 to the
is a multiplication. So if the problem had been 16 to the 1/2 plus x, that would be 16 to the 1/2 times 16 to the x. This is a multiplication. So isn't that just 16 to the 1/2 to the x? There's not another 16 in there. So that becomes 3 times 4 to the x. Okay. Everybody see that distinction? Which of the following functions is equivalent to that given one? There's only one answer. Which one is it? Okay, A, B, C, or D?
B.
B. You're the winners. B. Which of the following statements is correct? Let's remind ourselves what this looks like. It's regular growth. So A, B, C, or D?
A.
Why? It's going up, increasing, and it's concave up, which means it is increasing rate. Same question, number 14. This one is an increasing but flip, so it looks like this. 14 looks like this. So what about that one? That one is the little bookmarks mean repeat the word above. So what do you think about this guy? Increasing or decreasing? Decreasing at a decreasing rate because it's concave down, so that is C. Decreasing or decreasing rate. All right, let's take a couple of minutes and finish this page. Let's see if you can finish this page and we'll have your ideas up here on the board. Question 15 says find B plus C. So what is B plus C? If you have these, we won't put the multiple choices up, but 15, 16, 19, let's see your work.
how do you use this? Oh, well, this, when that picture or something, you get these
Yes.
No, I will.
Divided by 2, so then, oh yeah, so so that means, if this is geometric sequence, that means it's 548 by 1.
All right, Sam, for number 15, Sam got 34. He got B to be 3 and A to be 3, or B to be 3 and C to be 31, whatever the letters were. So he added those up and got 34. He had some work over here, which is beautiful. I tried to like draw a picture of it a little bit to clarify that. Everybody good with 34? 3 and 31 as our two numbers. Remember, arithmetic means every step is exactly the same size. So he knew that between these two, he covered 8. Each step has to be 4. So just back up, some 4s, go forward, some 4s, and get that. You okay with that? This one is exactly right. Y equals 3 for f of x equals 3 times 2 to the x. And how did he know his ratio or his base was 2? Well, he looked at what was given, which was, it always looks so tricky, but it's very, very easy. He was told that was 2. Well, in big picture terms, aren't these consecutive terms? Isn't this like f of 5 and f of 4? So they're terms right next to each other in the list. So their ratio, whatever their ratio is going to be, well, that is the ratio, right? This is going to be the ratio. So it's 2. He actually worked it out. He said this would be a times b to the x plus 1. This is a times b to the x. Obviously the a's cancel. And this is b to the x times b over b to the x. Those cancel, so b equals 2. And then once he knew that b was 2, he put, once he knew that b was 2, he put 2 in here. And then he plugged in his other point, which was 324. So 24 equals a times 2 to the third. And so a was 3. Nicely done. Nicely done. Anybody have a question about that? Don't let the way it looks scare you. All right, and nobody did, what's going on with 19? Nobody did that one. Did anybody have a thought? got this. And C is measured in centimeters. And the question says, okay, redo it, so it's in millimeters. We've done that before. Remember, we had something in, I don't know, years, and we had to change it to months, or it was in hours, and we had to change it to minutes. How do we do that? We alter the exponent. How would we alter our exponent this time? Shelley?
Multiply by 10.
Multiply it by 10. So basically, 30. What do the rest of you think? Actually, it's supposed to be M, so I'm 30M, Charlie, is that what you want to do to make that 30M?
I thought that the C was a 6, so I thought it was 3.
Oh, sorry about that. No, it's a C. You have to have a variable in order to calculate that. Alright, so could we check this somehow to see if it's right? So we know that 1 centimeter is 10 millimeters. Is that right? So both of these are supposed to give me the same answer. So if I put a 1 here, work that out, and I put a 10 here and work that out, am I gonna get the same answer? Kids, if I put a 10 here, that exponent, or excuse me, 1 here, that exponent's gonna be a 3. If I put a 10 here, that exponent's gonna be a 300.
My bad. I didn't
Maybe we should divide, and if we divided that by 10, maybe it should look like this. Now, if I put in 1 centimeter, that's what I'll get. If I put in 10 millimeters, which is exactly the same as 1 centimeter, do I get the same thing? Yeah. So there we go. Good job. All right, so tomorrow we'll finish this sheet and do the other sheet. And then we'll be ready for a quiz on Monday. So all the homework's been assigned for that, so okay.